Hello everyone, in this presentation I'm going to tell you about an interesting mathematical concept called tessellations. I'm also going to tell you how I found it in nature. A tessellation is a shape that is repeated over and over again, covering a plane without any gaps. They are also called tiling. The jigsaw puzzle pieces are an example of tessellations. They can also be found in building architects. You probably already know about symmetry. Symmetry can be found anywhere in nature. The beautiful butterfly and flower are all examples. There are three types of symmetry. There are translational, rotational, and reflection symmetry. I'm using the letter F as an example. If the F is slid across to another location, that is called translational symmetry. If an F is rotated, then that is called rotational symmetry. And if the F is reflected to each other, that is reflection symmetry. The star is a great example of symmetry. This is my research proposal. One of my questions are, why do animals and plants in nature have tessellations? And in the next few slides, I'm going to show you all my research. Of course, the answer to question 1 is yes, because there are many tessellations in nature. Tessellations can be found in animals. The honeycomb, snakeskin, and beautiful peacock are all examples. Now let me tell you more about the honeycomb. It has been 2,000 years of mystery that scientists tried to figure out. Why do bees choose to build their honeycombs out of hexagons, but not squares, triangles, or circles? Bees consume about 8 ounces of honey to produce a single ounce of wax, and they use the wax to build the honeycomb. So they would want to use the smallest amount of wax to build the coziest home. The smart bees discovered that hexagons can give them the most compact structure of tessellations. That means in the same space, the hexagon tessellation can fit more bees and use less wax. Take an example of using circles. If all circles, then you would need extra wax to patch the holes in between the circles. These are the tessellations I found in plants or in our daily life. Have you noticed the strawberry is also a tessellation, and the corn and the pineapple? They can also be found in a variety of leaves in the onions we eat. This is very interesting. The name of Fibonacci sequence, or Fibonacci numbers, came from an Italian mathematician in the 13th centuries who discovered the phenomenon. It is a series of numbers where the number is the addition of the last two numbers starting with 0 and 1. Fibonacci numbers can be seen in nature everywhere. If you look at the array of C's in the center of a sunflower, you'll notice what looks like spiral patterns curving left and right. Amazingly, if you count these spirals, your total will be a Fibonacci number. Now I just want to show you another few examples of Fibonacci numbers in nature. You can commonly spot these in various plants. For example, the number of petals on a flower are usually Fibonacci number. Take a good look at yourself in the mirror. It's amazing to see that our body parts follow the Fibonacci numbers too. You have 1 nose, 2 eyes, 3 segments to each limb, and 5 fingers on each hand. Now I'm going to reach my conclusions for this research. Natural selection can cause development of tessellation patterns in living things for their survival in nature. Nature is fascinating, full of mathematical concepts. I love mathematics and I love nature too. These are my citations. Thank you.